All right, up next, we've got Dmitry Meshkov, CEO of Quex Technologies based in Cyprus. His session is dives us into Oracle technologies, security challenges, and design strategies, something that ensures reliable and trustworthy data in our lovely centralized ecosystems. Please join me in welcoming Dmitry. I think it's your first time at Blockchain Professionals here with us. You're very welcome.
Yeah, sure. Hi, everyone. Glad to be here. Do you hear me well? First question, because I feel my connection might not be perfect. Uh, if
We
it's
can see
fine,
you perfectly.
I'll start. Yeah. Glad to be here. Dmitry Meshkov. Let me, as I'm first time here, let me introduce myself a little bit. I'm originally a technical guy with a PhD degree in physics. Been involved in crypto space for 10 years from now, first as R&D department at Input Output, then as founder of Web3 project like Ergo platform, Circle Gain, wrote batch of papers in cryptography, distributed systems, economy, all around the blockchain space. And right now, I'm working on Quex Technologies, C-based data and computation oracles. And today I'm going to tell you a little bit more about problems of data oracles and why it's so important. Why do we have this problem at all? Yeah, because a simple question you can ask when developing your decentralized applications, what your smart contracts are capable to do and what they can do. Yeah, or they can read data from your PC or run a desktop applications or make network requests, or for example, turn on the light on the sunset. Yeah, might be a smart contract, some kind of logics, but actually, it's not possible to do all of this logic directly from smart contracts because smart contracts have to be deterministic. It's the main um, difference, I believe, between Web3 development and Web 2.1. You have to keep in mind that the results of your program should always be the same. It's this requirement is coming from decentralized applications because you have a distributed network and all nodes should reach the same results, should find a consensus. What's actually happening here? Um, what is the output? So uh, if you have like output that is input plus 5, it's pretty simple. Yeah, input is 5, output will be 10. But if you need external data, for example, it may return different values for different nodes. They might have different permissions, different availability. They make their request in a little bit different timing. And if it's like prices, yeah, which is pretty popular in Web3 space, it will lead to different result, and they won't find a consensus. What was the exact response from Bloomberg API at this point of time? And the smart contract will fail. Yeah, the whole chain execution will fail. That's the Oracle problem. So smart contracts can only read data that is already on blockchain. And if you need any kind of external data, anything that is not in this particular blockchain you're building on, you have to bring this data on chain first, and only after that you can access to it from your smart contracts. So here is the place where special parties called oracles come into the game and doing their job for taking data from Web2 sources or from other chains and putting it on chain. Uh, there are different models how oracles works right now. I'll talk more about this during this session. Um, at this stage, I'll take they might do it on a push model, for example, updating Bitcoin price every 10 minutes. or on every 1% price change, or pool based. So if anyone needs the Bitcoin price right now, they can pull it and um, use it exactly at the point when they need. Traditional model is push based, so that's how Oracle started with pushing more and more data on chain. Actually, it's all started in a centralized manner. So we have some kind of trusted party that is pushing data on chain. But in this case, we actually lose all the benefits of distributed systems, of decentralized applications, because we have a trusted party. If we have trusted Oracle, we have a trusted party that can efficiently like change the state and steal all the money. That's why we definitely need decentralized oracles and Web3 space that have to provide some kind of proofs of the data correctness. It might be, mm, it might be proof that is consensus. We have a big network that come the decision that some data exists somewhere. It might be technical proofs. I'll tell more about this in this space. And I'll go in the numbers. I've already seen in the chat that's like 33% of attacks defined regarding Oracle. That's very big number. So 1 out of 3 attacks to DeFi protocols are coming through the price Oracle manipulations, data Oracle manipulations. This leads to hundreds of millions of US dollars losses every year. Besides of the fact that we already have quite a lot of oracles right now in the space, you likely know like Chainlink, Peace Network, API3, Redstone, and Quex definitely is a new player here in the space. I'm building it. So before starting Quex, I thought actually that Oracle problem is solved already. The reality is that the problem becoming bigger and bigger every year, and I expect that it might be a huge problem with upcoming years when Web3 space will finally find like adoption and will connect to Web2 space. We see a lot of these movements like tokenizing real world assets, so like in prediction markets, or traditional DeFi applications also. So we need data from um, different sources on chain, and the problem is not solved and becoming bigger and bigger. So as like that Oracle's party, I mostly see a very simple request. We just need a current Bitcoin price. So we have a protocol, DeFi protocol, and we need a Bitcoin price. But in this sentence, there are a lot of assumptions that are hidden, a little bit hidden. And when you're starting to talk with a client, you find out that they need a very accurate price, like this deviation 0.1%, with very low latency, few milliseconds, and they want it to be secure and decentralized and don't want to trust us or anyone else in this price feeds or other data feeds, because they can be hacked if data oracles they rely on will be hacked, and they will steal all the money anyway. We see a lot of DeFi applications with billions of dollars value locked, and right now, as I remember, like 60 billion of US dollars rely on data oracles. So efficiently, if you hack all data oracles existing in the space, it will be possible to steal tens of billions of US dollars. So the market is pretty huge in terms of stealing money. While it might be a very small, might looks like a very small piece, you have a huge application. The only problem here, you have untrusted price. Yeah, let's go further with the price example, and I'll explain why it's not that easy to deliver like Bitcoin's price. So the main, you know, mistake made by a lot of developers sounds like, okay, we have a DEX, we have like Uniswap on our chain or smaller DEX, and we can bring price, and Bitcoin is traded here, so we can bring price from the DEX. The problem here is that actually it's pretty easy to manipulate prices on decentralized exchanges, even on big ones like Uniswaps. That's where interesting example of flash loan attacks coming into space. They're still pretty popular. It was a nightmare 3-4 years ago, but still I see quite a lot of attacks that rely flash loans. The flash loan is actually uh, again a Web3 unique type of loan that you're capable to loan a lot of money if you'll return it within the same transaction. Yeah, so it's very safe for lender. I have $1 billion. I can put it on flash loan protocol and tell anyone who will return me 10% more than took within the same transaction can take as much money as they want. And then what they do, yeah, they loan hundreds of millions of US dollars, push the price up, go to the protocol that rely on prices from this DEX. Um, right now, the price is 2 times bigger on this DEX. Exactly at this point of time, yeah. Still $200 million, and then return 110 to the lender with a flash loan. The price goes down. Arbitrage will come into play pretty soon within the next transactions or the next block. But it doesn't matter because the hacker already got a lot of money with this attack. At the right side of the slide, I showed a few exploits related to flash loans attacks within the last, year maybe. You can check by yourself if you'll go, for example, to DeFi Llama. There is a special hack um, page on their website, and type of attack is stated here, so you can check attacks that are related to uh, data oracles. Within the last month, there were, I believe, 2 big attacks with tens of millions stolen. But sometimes they are very big, so you can see attacks that the hacker steals hundreds of millions, and that's definitely a death for the protocol. A lot of people losing their money, just because we don't care too much regarding the price. It looks like a very simple task, just the price, but we have to be very accurate here, because it's possible to steal a lot of money. The attack profit is very high, and it opens the way to create very complicated, sometimes very interesting attacks that also that are costly, but the attack profit is high. So yeah, okay, let's go and let's grab the price from the DEX. It's the snapshot, I think 1 month ago to 2 months ago, maybe. But the situation is still the same. If you go to different exchanges, to different pairs, we'll see different prices. And if you have a decentralized Oracle network, and one node takes from one exchange, another one takes from another one, from different pair, they still need some time to find a consensus. They might calculate an average of all their volumes, remove uh, some values that different significantly from the average price. So there are techniques how to find a good average price, but it takes time. Yeah, it takes time. We need a consensus among all of this nodes. And here we'll lose the point of bringing data very fast on chain. Yeah, sometimes we need it very fast, and it's crucial to have a very accurate price. So yeah, prices vary over time, vary over exchanges, vary over trading power pairs, and even like on tier one exchanges on pretty low volatility markets, prices might range with few percent. Um, People solve this, trying to solve this issue by describing exactly the algorithm, how they calculate the price. Yeah, that's what we see in Hyperliquid, for example. So you take Binance, OKX, other exchanges, they all have weights. And in some conditions, we take Hyperliquid prices if there is a spot market. And so there's exact set of rules for all the nodes, what we consider as a price. Because to find the truth actually is not that easy. We'll see it a little bit later in different examples, not just for prices. But yeah, for when we define the price like that, at least we have the rule how to calculate it. We can find a consensus how we calculate it. We still have problems with the timing, yeah, because we may make requests on different times, but at least we are doing the same calculations, the same aggregation on our side. So that was the um, price example, and it's called like multi-party computations, MPC design. So we have a lot of nodes that are making requests the same data sources, or maybe the different data sources, it might depend. They calculate their own result. They run consensus among themselves to find a final number, yeah, and push this final number on chain. This approach is very good for like traditional oracles push-based, when you have pure stable like price feeds. So you have we know that in a lot of cases DeFi applications use Bitcoin price. So we can push Bitcoin price, and all the DeFi applications that rely on it can take it from like known smart contracts that contains this price. And actually, it's a pretty good approach. However, it's pretty slow as we need a consensus among different nodes. It's not that easy to add new data feeds because through all the network we have to agree that right now we're also calculating a new price feed and starting to push it to this contract. Yeah, that's a new that's some kind of update. We have to update all our nodes. They have to know where to go to get the numbers. And I'm talking just for numbers right now. It's pretty simple number with like price. And the last topic I would like to emphasize here is very important from my point of view, is a kind of security guarantees you're getting from the concrete approach. And in a lot of cases, for data oracles, especially in MPC design, your security guarantees are like economic. So Chainlink have its own token. We have to stake this token to become validators and start to participate in the validator networks, run the consensus, get rewards from this price. But the issue here is it's possible to buy a lot of tokens, perform 51% attacks, or like bribe other validators, telling them, "Oh, I'll pay you big amount if you'll push incorrect price." And it's not just theory. We'll see it a little bit later. The problem here is that none of oracles are capable to provide this kind of guarantees. So well, uh, every project, every like Oracle that relies on security guarantees like that secures much more than the token market cap. Even if you're talking to Chainlink, like the biggest Oracle right now, the token market cap is for about 10 billion, but they secure 40 billion. So there is a 4x potential profit if they will behave like dishonest, if they will behave economically rational, actually, if they push the data they need and just steal money from the protocols they're securing. It's pretty dangerous situation, I believe, in decentralized applications. We don't want to trust to anyone. We don't want to rely that parties will behave honestly, will behave as good actors. Yeah, that's why we have technological guarantees, cryptography, and all of this stuff. Yeah, I just thought about all of this. Yeah, for Chainlink is 44 billion in maybe a month ago, but it's still possible to steal a lot of money. Yeah. That's method calls total very secure. It's pretty public. You can check from different oracles how much they secure. And you can check actually how they secure these tokens and how much money do you need to break this kind of security. For Chainlink, you need a lot of money, but the reward is also pretty big, very big actually. So keep that in mind, especially if you're building applications that potentially will secure a lot of money. Um, so I told regarding MPC design that it's good for secure, stable price feeds. But what if we are looking for like unstructured data for about, for example, prediction markets make bets for different events, event results, or election results, or some events happening in blockchain space or outside of it. Uh, Here, optimistic oracles usually come into play. The most known example is Zoomer Oracle, serving as an oracle for polymarks, and it works like that. So we have um, an event, and we want to resolve this event. In most cases, it's yes or no, but there might be more options. So, just will Trump will be a president of United States on July 1st? And we can make bets, and someone have to resolve this event. Yeah, curious and optimistic design means that there is optimism that we believe that everything will go quite good, but we have a protection against uh, misbehavior here. So a sort of sends the data points on July 1st. He says, yes, Trump is still president, and challenge period started. Any other participants of the network can start a dispute telling that now that sort of sent incorrect data point. They have like 2 hours in most cases. So within 2 hours, they can start a dispute. If dispute is starting, the voting for correct result is starting. It's pretty slow and manual process taking a few days, like 1 day maybe. So people are starting to what exactly happens at what events. And there are rewards to correct voters. There is punishment for incorrect voters. It's again rely on economic security guarantees. So you vote with your tokens, UMA tokens or Oracle tokens. Dispute process is very slow. Hopefully, they're slow only when dispute started. When dispute not started, it might be more or less fast, but again, it's not real time. It's a few hours because we still need this time to start disputes if anyone send incorrect data. And for unstructured data, it's pretty good design. The problem is surprisingly sometimes it's not that easy even for us as a human to realize what is the truth. Yeah. So for blockchain, as I told, smart contracts have no idea who won yesterday's football match. Uh, for me, it might be pretty easy. I go to sports website, or maybe I watched this match live on the stadium, and I know the team, the exact team won yesterday. But there might be cases when it's not that easy. The match might be cancelled and so on. So there was a pretty interesting issue on Polymarket a year ago regarding Ethereum ETFs approved. So the question of prediction market looked like Ethereum ETF approved by May 31, but it wasn't stated what exactly approved means. Yeah, and there were there are different forms and regulation that have to be approved before uh, going live, and 19B for form was approved, but the second one, F1, wasn't. It's not that easy for regular people even to understand was it approved or wasn't, was Ethereum ETF approved or not. So it was approved, but it wasn't possible to trade it on public exchange, so that you can launch. And there was pretty big conversation in social networks and community Polymarket whether how we can resolve this kind of issues, because we missed likely at the early beginning. Yeah, we missed to define exactly what approved word means. That's I'm telling this to you just to realize that sometimes it's not that easy to understand the truth, to answer a very simple question. Yeah, very simple question with yes or no response. Both can be easier, but in this case, it happened that it's not that easy to realize was it approved or it wasn't. The second example from the same polymarks I'd like to show to you is more interesting, more fresh from this year, and there was a bet uh, like Ukraine agrees to Trump mineral deal before April. In reality, the deal wasn't signed, but markets resolved as yes on March 25. For sure, community initiated the dispute that is incorrect response, but it was finally resolved to yes on the same day because few whales voted that this market yes. Yeah, and it's like 7 million losses for ones who bet to no results, and uh, 7 million win for ones who bet for yes result. The problem here is the voting power. If you go to the right bottom side, you'll see the distribution of voting tokens among top holders. You'll see that just two accounts hold 51% of that. We have this issue actually even on public blockchains like Ethereum, Solana. Yeah, we have this concentration of voting power, of hash power, if you're talking about proof of works um, blockchains. Uh, if we rely additionally on oracles, we have the same issue. Yeah, we have two levels of this issue. There might be like 51% attack on low level, on the blockchain level, that might steal a lot of money from different projects. And again, also additionally to that, we have this potential problem in Oracle's setup. The one example I'd like to show to you is a private Oracle. Pretty fresh space, just because technically people were not capable to do it just like 3-4 years ago. The problem with the prices or with bets, it's not an issue to push data on chain. But if we're talking about sensitive information, user belonged information, we cannot push it on chain for just as is. Yeah, it's just illegal. The simple example here is, for example, you want to show that you are a accredited investor and you have 100K on your bank account. You might want to show this to prove that you are eligible to do this, to participate in this DeFi protocol. But if you provide the whole response from your bank, it will contain your passport number, name, surname, distribution of your assets, your money among different assets, the exact amount of money you have. The only thing you need is to prove that you have access to this 100K account. Yeah, but you don't want to reveal your name, surname, and so on. So this, like private oracles, we also belong to them. Usually injects in TLS and encryption piece of communication pretty standard, and can like certify every single HTTP request, proving that right now this data source return this response. It's not necessary. We have to extract only necessary information from the response and push it on chain. Yeah, that's good for private data that is suitable for user-centric data, specific data. You have to trust to data sources. Keep it in mind anyway, because if we are bringing prices from exchanges, usually bringing it from a single one is not a very good option. If we are bringing sports events results from sports API, we have to trust the sports API. If we are bringing data from a bank, we have to trust this bank. It's not a complete truth. Yeah, we don't prove here that a user owns 100K. We prove that right now bank responds him that he owns 100K. So it's again very very small difference in definitions, but it might significantly change the vision how we hold this. And finally, I have to mention here that in most cases for these private oracles, we have very non-trivial security guarantees. They might rely on trusted execution environment, trusted hardware. That's what we are doing, for example. But in this case, we have to trust to manufacture this hardware. We have to trust them anyway, actually, like to Intel as a manufacturer. In our case, it's more crucial because we rely a lot on the verifiable like confidential computing features. We rely on confidential computing proofs. It might be a zk-TLS approach that rely on zero knowledge proofs, but again, ZK is pretty fresh, non-standard cryptography that's widely adopted, but it's not as secure as a standard cryptography we use every day. So again, keep it in mind in lots of cases that it's okay to trust to hardware manufacturers like Intel, or few of them. In some cases, you might not want to do it. So yeah, finally, I'll tell a little bit more about Oracle work. One more approach we have is like first-party oracles, where data providers itself install special software on their site and correctly sign the data that we can verify it right now. So if all the internet would be like that, in most, I believe we wouldn't have Oracle problem. But unfortunately, responses from most APIs, most websites are not signed, and you can ensure for yourself. I can ensure that it's response from Bloomberg, but I cannot prove it to a third party. I can convince a third party that Bloomberg returned me this response. That's again a big difference actually, because we already have an internet. We have a lot of cryptography under the hood of our browser and every connection we use. But yeah, I cannot convince anyone that I got this response from my colleague who told me something via Zoom. Yeah. Few more things that typically oracles do. It's again goes back to one of the first slides from my side. So smart contracts have to be deterministic. Network requests are not deterministic. That's why oracles solve this issue. If you need a pure randomness in your smart contracts, you cannot get it like out of the box in smart contracts. That's why you have to rely on verifiable random functions. Most of oracles provide this functionality also. So just randomness, but verifiable. Oh, it looks like, yeah, I hope you hear me and see. It looks like electricity turned off in my city. Okay, I'll continue like that. Interoperability problem is also pretty new, because we have a lot of chains, blockchains, and I told that like smart contract can extract data from the exact blockchain it is running. So if you're building on Ethereum, you cannot get data from Solana or from Bitcoin or from Cardano. Yeah. So this kind of cross-chain messaging for bridges to bridge assets among different chains to build multi-chain apps is important to create a world where final users won't care the blockchain under the hood and will just use the app. And there are more interesting cases like automation. It's related to a little bit different problem. It's related to the problem to initiate a smart contract. You need a user. You need a user who actually start a transaction. So smart contracts can't start by some conditions. That's why oracles might also initiate execution of other smart contracts. It might be just timing every hour start something, or condition based, like if the price changed 1%, start execution of the console of football match ended. We push the result and execute the resolution of betting apps. So the conclusion I'd like to tell today, I wanted to show to you that the Oracle problem is pretty unique for Web3 space. If you're a Web2 developer, you don't know what is Oracle, but it still remains unsolved, and it's growing in the scope and the space. There are different trade-offs for different Oracle models. You have to choose very carefully how to grab what kind of Oracle to choose. and how to use it actually. Also, oracles provide everything a part of basic smart contract functionalities. So if you need anything that is not supported by smart contracts, took a look to oracles. Likely they do it. It might be randomness, cross-chain messages, verifiable AI inference, whatever you want. And yeah, Oracle defined the trust and execution boundaries of Web3 applications. So thank you for your time. It was a pleasure to be here. I'm ready to answer questions if you have some time. I think I took exactly 30 minutes as I should. So
Do not have much time, but I think we can take one question if you could answer to it very quickly. I think it's very interesting. Here it is on your screen.
Okay, I see. So will the next 1 million DeFi hack come from Oracle manipulation of Trump's smart contract flows? I don't know exactly what will happen in the future. I think we have a very good chance that it will come from Oracle manipulation. Smart contract flows in most cases are pretty good if people knows how to work with smart contracts, how to make security audits. So I see not that much hacks right now from badly designed smart contracts. In most cases, the hacks coming from side channel attacks, not the main logic of smart contracts, but from oracles or logic that economic attacks like that. So yeah, I believe we have a very big chance that it will come from oracle manipulation. Definitely there are hacks like stealing private keys, hacks from centralized exchanges. Still the biggest in the space. Likely you all heard about 2 billion hack from Bybit this year, the biggest hack in the history. But yeah, just keep in mind it's important to remember that oracles are also vulnerable, and it's additional level of security, but additional risk to your funds if you're using blockchain or to your protocol if you're developing there.
All right, Dmitry. Thank you. Thank you so much for your insightful look to how blockchain connects the outside world through secure data oracles. It was a pleasure having you on stage, and you're very welcome for our next sessions.
Yeah, thank you very much. It was a pleasure to be here. Have a nice day, everyone.
Thank you.